Okay, so now we are going to do problem number 16, chapter 18, page 660. All right, so I'm going to do a few problems for you guys so that you will know some of the harder problems. Now, the question is, there are three charges. The first charge is positive 4 microcoulombs, and then the next one is positive 6 microcoulomb, and they are 10 centimeters apart. From here to here is 10 centimeters. And in the middle of between these two charges, then there is the third charge. They call it the test charge, which is Q3, which is positive 2 microcoulombs. When I say microcoulomb, micro means 10 to the power negative 6. Before we had used nanocoulomb, which is 10 to the power negative 9 coulombs. So microcoulomb will be 10 to the power negative 6. And this is 5 centimeters, so we have to convert it to meter. So that means we have to multiply by 10 to the power negative 2 as usual. So the question, the answer they want is, first of all, they want to know the magnitude of the net force on Q3. Because there will be a force coming from Q1 and there will be a force coming from Q2. Whoever is bigger will win, right? Because both this charge and this charge is positive, so it will push away this Q3 to the right, and Q2 and Q3, both of them are positive, so Q2 is going to push this Q3 to the left. So those two forces, the one coming from Q1 and the one coming from Q3, Q2, whoever is bigger will win. All right? Now, you can sort of guess, first of all, the distance between these two charges is 5, and this distance is also 5 centimeters. So the distance is the same. Then look at that. This is 2, this is 6. So this is 6 microcoulomb, but this is 2 and this is 4. So this is 4 microcoulomb. So obviously the force coming from 6 is going to be bigger. So the net force will be towards the left. Okay, so we can tell that. But anyways, let's work it out. So the first thing is I want to do part A, F13. That is the magnitude of the force coming from Q1 on Q3 will be K Q1 Q3 divided by the distance squared, which is R13 squared. R13 is the distance between Q1 and Q3. So let's substitute. K is 8.99 times 10 to the power 9 Newton meter square per coulomb squared. And then Q1 is equal to 4 microcoulombs. So I put 4 times 10 to the power negative 6 coulombs. And then Q3 is 2 microcoulombs minus 6 coulombs divided by R13, which is 5 centimeters squared. So that's 5 times 10 to the power minus 2 meters squared. So when you do that, you can see that meter square cancel out. Coulomb square and these two coulombs cancel out. So the answer will be in newtons, which is correct because this is a force, right? So let me work it out. So I have 8.99, that's this guy. I have 4 times, this is 2, and then 5 squared is 25. So these are all the numbers in the front. Then I look at these digits, exponents, 10 to the power 9, 10 to the power negative 6, 10 to the power negative 6. And then at the bottom you have 10 to the power negative 4. And the unit will be in newtons. Right? So now I can work this out, and this, if I work that out, it'll be 2.877. If I'm wrong, please let me know. And this one, look at that, 10 to the power -6 and -6, that will be -12. With +9, it'll be -3. But in the bottom, there is 10 to the power -4, so then you have 10 to the power -1 left in the denominator. So you take it to the numerator, it'll be 10. So actually all you have to do is add these numbers up, take this guy to the numerator, then you will get the answer. All right? And the answer is 28.77 newtons. So that's magnitude of F13, and direction is in towards the right, because this is positive, so it's going to be pushed to the right in the positive x direction. So I'll say, just say to the right, or towards the 6 microcoulomb charge. That is F13 magnitude. The next thing I'm going to do is F23 magnitude. Then again it'll be K, Q2, Q3, because this time it's between 2 and 3, and the distance are 2, 3 squared, which is also 5 centimeters. So if I put in the numbers, again 8.99 times 10 to the power 9 newtons meters squared per coulomb squared, and then I have Q2, which is equal to 6 microcoulombs, 6 times 10 to the power -6 coulomb, and then Q3 is 2 microcoulombs, 2 times 10 to the power -6 coulombs, divided by 5 times 10 to the power -2 meter squared. So I've already worked out the answer. It is 43.15 newtons, right? So you should do the same thing, work it out. Now this guy is going to be pushing this Q3 to the left, right? Because this is positive, so this is going to be pushing this Q3 to the left. So I'll write to the left. So now look, when I write to the left, this F13 and F23, which one is bigger? F13 is 28.77, F23 is 43.15. So F23 will be bigger, so, and it will win, so the net force will be directed towards the left. The net force is, magnitude is F net, magnitude is equal to 43.15 minus 28.77 newtons. And that is, let me do this calculation. So 43.15 minus 28.77. Sometimes I plug in things wrong, so let me know. And the answer is 14.38. So that's 14.38 newtons. That's the magnitude. Answer for part A. And for part B, since the force from Q2 on Q3 is bigger than the force from Q1 to Q3, the net force will be directed towards the left. So the answer is to the left, or away from the plus 6 microcoulomb charge. Okay, so That's it. That's the... So, by the way, I don't think you saw what I wrote. So what I did was I subtract that, and then I get this 14.38 newtons, and then the direction is to the left or away from the positive 6 microcoulombs. All right? Okay, thank you. So we'll do the next problem.